Let's look at this example here. Now, from the previous video, we considered the inner integral. Now, since we are integrating x e to the minus y squared with respect to y, we treat x as a constant, so we can take x outside the integral sign. Now, unfortunately here, we have an integral that cannot be evaluated by algebraic methods. We can only use numerical methods, which we won't go into. However, let's see what happens if we just leave this integral as it is. It's obviously just going to be some function of y. Okay, because we're integrating a function of y alone. That's what this is. No x appears here with respect to y. We could even write this thing here as x times h of y. We can call this integral h of y. It's a function of y alone. So we can write our problem like this: x times h of y dx. We don't know what h of y is because we can't solve this integral algebraically. But you see now that since we're integrating this quantity with respect to x, y is treated as a constant. So we can take h of y outside the integral sign. Integrating x with respect to x gives us a half x squared. If we plug in our limits, we get a half times 1 squared, which is a half. Then we have a minus sign. We plug in the lower limit, minus 1. We get a half times minus 1 squared. That's a half. So you see we end up with h of y times 0, which is 0. So we actually have solved the problem without knowing what h of y is. It's just convenient that the integral of x dx from minus 1 to 1 worked out to be 0. And h of y times 0 is 0. The moral of the story here is that if we're getting the double integral of some function which can be written as a function of x times a function of y, as this thing can be done, it can be separated out like that, we can just integrate each function separately and multiply the two integrals. So in general, we are saying that if our function that we are integrating can be separated out like this to a function of x times a function of y, where I'm calling the function of x g of x and the function of y h of y, then we have to evaluate two single integrals. We integrate the function of x with respect to x and multiply that by the integral of the function of y with respect to y. Now let's look at this example here. We want a double integral of y squared. This integral is actually over a rectangular region. The inner integral is this one here. So we can integrate y squared from y equals 1 to y equals 2. And we take the result of that integration and integrate it from x equals 0 to 1 with respect to x. Okay, that was the method of the previous video, but we can use the method of the previous example. We can think of y squared as a product of a function of x and a function of y, where the function of x is just 1. Okay, so comparing to the general case that we covered previously, g of x is 1, h of y is y squared. So we can integrate our g of x with respect to x and multiply that by the integral of our h of y with respect to y, just like we saw before. The integral of 1 is easy. The integral of 1 with respect to x is just x. And we want to integrate y squared with respect to y. It's a third y squared, or a third y cubed. Sorry. So we integrate, our limits are from 1 to 2 here. Now notice when we integrate 1 with respect to x over the interval from 0 to 1, we are just getting the width of that interval. Okay, we're just getting 1 minus 0. So that's the width of the x interval. So in general, if we're getting the double integral of a function of y alone, we just have to multiply the width of the x interval, which in this case is b minus a, and in general it's b minus a, times the single integral of h of y with respect to y. And here the limits in general are called c to d. In a similar way, if we are getting the double integral of a function of x only, we can show that it's given by the width of the y interval, in this case it's d minus c, times the single integral of the function of x with respect to x.